Oh hi, good to see you there. I'm Isaac, and I'll be explaining Bézout's buckets and pond theorem. Let's take a look.
The basic concept is you have two buckets of water, a water butt that will find in any volume of water, and a pond which you can either add to or remove water from.
What about 13 litres with these two buckets? If you use the 9 litre bucket twice, and then carry 5 litres back from the pond, then you have added 18 litres and subtracted 5 litres, leaving you with 13 litres added. However, it is not possible to make any number of any two buckets. For example, it is impossible to add 5 litres to the pond using only these two buckets. After a few experiments, a pattern appears. All combinations of 2 and 4 are even numbers. The same is true for any two pair of even numbers. The only possible combinations are all even. From this, we created this simple equation.
Because of the clear pattern of even numbers, we tried to combine two odd numbers in order to find a pattern of them. For many of these, any number was possible. For example, 5 litres and 7 litres.
They can make 24 litres, 11, or even just 1. However, with some odds, only certain multiples can be made. For example, with 3 and 9, only multiples of 3 could be made. This is because for any volume the 9 litre bucket could carry, you could carry it in buckets of 3 litres, making the 9 litre bucket essentially useless. Because of this, we came to the conclusion that if one number is a factor of the other, only multiples of the small number can be made. We then decided to try this with 33 and 55 in order to experiment with large numbers. As 55 is not a multiple of 33, we expected any number to be possible. However, after a few attempts, it became apparent that many numbers were impossible to make. The only numbers that we could make were multiples of 11, such as 11, 22 and 44. We realised that 11 was the highest common factor of 33 and 55, and so we experimented with 2 other numbers which had a relatively large highest common factor, such as 6 and 9. As well as 16 and 20. After a few more experiments, we came to the conclusion that the water transfer can only be a multiple of the highest common factor of the two volumes of the buckets. For example, two numbers with the highest common factor of 1, such as 5 and 7, can transfer any volume of water, and while two buckets that hold even volumes can only transfer even volumes in total, as the highest common factor will always be a multiple of 2, although it may be higher, such as 4 and 8. From this, we tried to find a way to calculate the highest common factor, and came across Euclid's algorithm. With Euclid's algorithm, you simply divide the larger number by the smaller number, but keep the remainder instead of making it a decimal. For example, with 165 and 105, you divide 165 by 105. That comes out to 1 remainder 60, which is written as shown. The process is then repeated, divided by the remainder, i.e. 60, which comes out as 1 remainder 45, written as shown. The process is repeated until a calculation has no remainder, at which point you have found the highest common factor, which in this case was 15. If the highest common factor is 1, then it will get to a point where the remainder is 1, such as with 5 and 7. From this point, the process no longer works, as you have found the highest common factor. I hope this presentation has further explained Bézout's theorem of buckets and ponds to you, and on behalf of everyone in the team, thank you for watching.